Hello, Code Monkeys! Today we will be looking at linked lists, and most programming textbooks and courses usually introduce them after arrays because they are sort of a counterpoint to how arrays work. But I haven't made the array video yet because it's boring. We'll get around to it eventually, but let's dive into linked lists. This is where the surprise tool that will help us later, that was the node structure, comes into play. And start off with a nice ls here. We should already have something called linked list, so we'll just go ahead and clear that out with our same echo command we always use for these kinds of things. Alrighty. This one is a bit more complicated, and I'm hoping we don't get lost in the weeds like we did on the, was it the structures or the pointers video? I think it was the pointers video. We're not actually going to use malloc for this, so that means the only thing we're going to need is standard library, .h. And main's always going to return an int, and it's always going to take an integer argc, and character double pointer argv. Try to remember to return 0. And since we are going to be making a linked list, we will want our type def struct. I don't like doing my braces that way. I try to avoid it if I can. Aha, data is going to be an int just for demonstration purposes. And in order to link the list, we need a pointer. And it's going to have to be a void pointer. Now all we got to do is make some nodes. Node 0, node 1, node 2. We could create an array of nodes, but that would be a bit redundant. I would probably do it that way if this were a more real type of project, but for demonstration purposes, I think it's handy to not have that. And let's go instantiate some values. Ooh, our favorite number. Next. That's our handy dandy reference operator there, that ampersand. This number isn't as good, but you gotta use more than one, right? And our reference operator again for node 2. And we're not going to link node 2's next to anything. Some lists will have that circularly linked back to node 0. Sometimes there's a head node and a tail node. It very much depends on your application, but let's stick with the basics for now. This is actually kind of fun. We're going to use a very irregular for loop here. We're going to need a node pointer, and it will be called this node. Handy, right? And this node is going to be equal to the reference of node 0 is where we want to start. Don't need that space. Probably wouldn't hurt anything, but I like to save characters sometimes. This might not be immediately obvious why this is our test condition, but it will become apparent later. And when we update this node, we want it to be the next node. That should do it there. And we're going to print f, because that's how we see stuff. Alrighty. I think the way I had this rigged up when I was testing this was we're going to give our node a handy dandy name, and that name is just going to be its reference. And we'll, of course, want to know its data. And we're going to want to see what the next node is. Ooh. Spelling's hard, kids. Alrighty, that's looking okay to me. And we want to cast it as a Ling integer. Of course, of course. And our next one is just going to be this node, that handy dandy dereference and scope operator, all in 2 convenient keystrokes. This node, data. And we'll go ahead and get a little wacky with parentheses here. Long integer. This node, next. That should let us see everything. Now, there's nothing wrong with leaving it all on one line like this, except that I don't like it when things run off the end. C doesn't care about white space. Very handy for us, so we'll just break that into 2 lines there. And that should do it. A little bit of an explanation before we get started. We're going to initialize this node, the pointer that is called this node, to the address of node 0, and then at each step of the for loop we're going to grab the pointer to the next node out of it and store it back in this node. And pointers are, happily enough, initialized to 0 if you don't touch them, so you will know if you're working with an uninitialized pointer fairly easily. C likes to throw errors that, let me see if I've got this right. It will say segmentation fault, and it will give you absolutely no further information about it. So checking your pointers to see if they are 0 is very important, because that is one of the things that will cause a segmentation fault. Enough babbling, let's try running it. Compile it with the usual GCC line, force ANSI compliance, give it the output file. Oh, come on. Linkedlist.o and linkedlist.c. Ah! Ooh! There we go. Incompatible implicit declaration of built-in function printf. Okay. Aha. Oh. Did I bungle that? Aha! Like I say, spelling is hard. Very important, very difficult. There we go. Would you believe I got it right when I was practicing? Oh, we haven't actually executed this yet. Linkedlist.o, and as you can see, we have... It's my... Yeah, my cursor appears. Okay. So we're just referring to our node by its memory address, and we've got a handy-dandy memory address there. It's got the data we told it to have. Very nice, very nice. And we've got another memory address here. Look at that. And you can see that the next node in the list has the correct memory address that matches the one above it. And that's true again down here. Pardon my bad mousing. And our uninitialized pointer in node 2 is in fact a 0, and that's how we detected that we were at the end of the list. There is a lot more to talk about with linked lists, but I think as an introductory video, that will do it for today. I hope you all learned something, and have a good one.